All right, so this is problem 6.9.41, and we have the intensity I of light from a light bulb varies inversely as the square of the distance d from the light bulb. And we want to suppose that I is 250 watts per meter squared when the distance is 3 meters, and how much farther would it be to a point where the intensity is 160 watts per meter squared. Okay, so the first thing is that we need to find the variation constant in this problem. So because it tells us that we're varying inversely as the square, our k is going to be on the top and our distance d is on the bottom. So that's the inverse relationship, is a fractional relationship there. And they're telling us the square of d, so that's why I have that there. And then to find our k, they give us these values here. So 250 is going to go in for the I, and 3 is going in for the D. Okay, and if we solve this for K, this 3 squared here is 9, so I'm going to go ahead and multiply both sides by 9 to clear that fraction there. And K is going to be, I believe that's 2250. Okay, so this equation now becomes I is equal to 2250 over D squared. All right, so now we need to go and take a look at their question. So they ask how much farther would it be to a point where the intensity is 160 watts per meter squared. Okay, so they're giving us an I value here, but for the distance value, they're not telling us what that distance is. What they're doing is they're saying how much farther would it be to this point. So we're actually looking at being farther than the 3 meters. So what I'm going to do here is I'm going to actually let x be the distance, the additional distance that we're trying to find here. Okay, and so the additional distance, if I take that and I add 3, this now is representing then the total distance. And so we're going to actually plug that in for our D here when we plug the 160 in for the I. Okay. All right, so if I plug those values in, it's going to look like 160 equal to 2250 over x plus 3 quantity squared. And again, that's me plugging in x plus 3 for the D and 160 for the I. Okay. Now we just want to solve this for x, so I'm going to go ahead and multiply both sides by x plus 3 squared, and so I can get that out of the bottom and into the numerator. So we have 160 times the x plus 3 squared equal to 2250. Okay, and then divide by 160 because we want to isolate that x plus 3 term. And the 2250 over the 160 here is what we're looking at. Okay, so I'm going to take the square root of both sides, and because we want to be able to solve for x and it's inside a square, so if I take the square root, then that x plus 3 will pop out, and we're looking over here at plus or minus the square root of 2250 over 160. Now, let's go ahead and plug this into our calculator. So go ahead and plug in 2250 divided by 160, and you're going to get 14.0625, and then we're going to want to take the square root of that. Okay, so if I take the square root of that number, you actually get 3.75. All right, and if we continue to solve for the x here and subtract 3, then we're looking at x is negative 3 plus or minus 3.75. Now, because we're actually looking at a distance, it doesn't make any sense to have that be negative. This is actually two things here, negative 3 minus 3.75 and negative 3 plus 3.75. but this one makes no sense because it'll be negative, and negative distance doesn't work there. So if we just do this calculation, 3.75 minus the 3, then we find here that x is equal to 0.75 or 3/4. The program will accept either answer. And that would be it in this problem.